up on example 5. And with example 5, follows the same idea as the last problem. Table 1.4 shows us average life expectancy for persons born in the United States in each given year. The data are drawn from census years between 1950 and 2010. Model the trend graphically and use the graphical model to suggest an algebraic model. Okay, so again, we're doing a similar thing to what we just did, and that we're going to look at these points. We're going to decide graphically what shape these points represent, and then we're going to come up with an equation, thus the algebraic part. So, do you remember anything about the calculator?
List.
Okay, so you're going to want to go where I had you guys going at least, is I had you going into stat, right? And when you go into stat, it brings up this menu, and then I just have you hit enter on edit, and it takes you to your list. Now, you probably still have numbers in there left over from last week, yes? So, you have an option. You can delete individual numbers, or what I like to do is I like to clear the column. So if you do clear enter, it will clear out the whole column, and I'm going to have to re-enter either L1 or L2 into Tanner's calculator because he just deleted the column. So, okay, still, clear out your columns. Okay, so do a clear enter. Oh, I didn't want to clear that one. Dang it. I was trying to save my numbers. Okay, and type in your numbers here. Okay, type in your numbers. Oh, we didn't talk about. What are you putting in for what?
0, 10, 20, 30, 40, 41.
Okay. So years after 1950, we're going to put into L1, and life expectancy is going to go into L2. Now, let's see if I can remember right here how to do this. Would you delete L1 and L2?
Yeah.
Man, you're good.
Yeah. Bless you, bless you.
Yeah, cool thing I figured out is it even brings your numbers back with it. Not that you need those, but so clear enter.
Clear enter. Perfect. Why is it even an option to delete all the way?
I don't know.
What?
Get your columns entered, please. Okay, guys. I have fixed the calculator, got mine entered, so you should have yours entered by now, right? Okay, now, to graph these. If you recall on Friday, just trying to remind you, at the time, you don't have to do this today, we went into stat plot here, right? If you recall, I went into second stat plot, and we had to turn our stat plot on. Okay, so those should still be on from Friday, right? Now, when you go to graph, just go ahead and hit the graph button. I'm not going to hit mine yet because I know my settings are, Do you see any dots on your graph?
No.
And why not?
I don't know.
Do you remember Friday? No.
What's the question? I mean,
Okay. Right now, if you go to the graph, you don't see numbers on your graph. Or you don't see any points on your graph. Let's go into our window settings.
I remember.
If we go into window, it should be showing mine because I've already done mine. And I haven't reset it. You guys, what? On Friday, our X's went from 0 to 10, yes? Does 0 to 10 cut it for our X's this time? No, what do we need this time?
0
0
to 60.
to 60 at least. I think on mine I did 0 to 65. That gives me a little, takes me a little bit past. So I would make your x's 0 to 65, something like that. 0 to 60, 0 to 70. Now, what about the y's? On Friday was what, 0 to 50 I think we did? Does 0 to 50 work for me? Well, no, you're going to have to go up to, you can't just go up to 50. You probably need to go up to 80. Now, is 0 to 80 okay?
Probably. Yeah, it is.
Okay. And here's what I'll say. So, if, and I'm actually going to change mine off of 0 here in a moment, but I have 0 to 65 and 0 to 80. If I hit graph, notice my points are all the way at the top of the graph. It works. Do we really need to go all the way down to 0? Look at my y's. My lowest y value is 68.2. I think this morning, instead of going 0 to 80, I went 65 to 80. And what it does is it just kind of narrows your graph down and it zooms it in some. So, x min 0, x max 65. I don't usually touch x scale. Y min, I put 65 because my lowest value is 68.2. Y max, I put 80 because my highest value is 78.7. I don't touch any of the rest of that stuff. I let it do its own thing. Now what happens when you graph it? You have a nicer view of the graph, yes?
Yep.
Okay. Now, do me a favor real quick. Did you guys have anything typed into y equals?
No.
If you do, go ahead and clear it out. You can just touch y equals, clear it out, and then you can go back and touch graph. Okay. Calculator's good? Now, is that a parabola again?
No.
No, it's not curved like a parabola, is it? Thoughts? What graph that is? What shape that is? What are your thoughts?
X cubed.
I wouldn't say x cubed.
X.
Wait. It's cubed 3.
Yeah. No, I wouldn't say x cubed.
X. What?
Okay, now you're just randomly guessing things. Go with something you know. This is something we know.
X squared? Ah, that's parabola. What else do we know?
I might have just heard something.
X.
Somebody, somebody said something.
Square root of X. It looks Jack. I'm gonna get mad.
What'd you say, Eli?
It's just X.
Just x is in, what shape is this representing?
Say that goes like.
Mx plus b.
Is it kind of like a line?
Oh.
No.
No, it's curved.
Okay, here, guys, keep in mind. Okay, think. These points, yes? Okay, well, the years after 1950 are exact. Life expectancy. That's not going to travel at an exact rate, but general trend, is that following the general trend of a line? Okay, thinking kind of like, you guys remember working with scatter plots. Where scatter plots, you'd have points kind of scattered around, but they follow the general trend of a line. That's what we're looking at here, folks. My graph is turning off, but we're looking at that these points trend to forming a line. Yes, I know in our parabola, all the points were exactly on the parabola, but that's not always going to be the case. Okay, so we are thinking here that this is going to be more of a linear form. Now, I'm going to put just a little sketch over here, not that you have to have detail here, but that our x-axis was years after 1950. The y-axis represents life expectancy. And just the idea that these dots, what do we have? 7 total dots, I think. you know, no, they don't go exactly through anything, but they trend towards a line, okay? And that's what I need us to look at. So the idea of this is a linear relationship is what I would go with. What form, I heard someone say it, what form do we think about for a line or a linear relationship?
X. Well, if, yeah.
Okay. Generally, when we think about a linear relationship, we think about it in the form y equals mx plus b. If we're talking y equals mx plus b, okay, I want to write the specific equation based on my data. What do we have to know? We have to know slope, don't we? What else do I have to know?
B.
B, which B stands for y-intercept. Okay, thoughts on any of these? Okay. Why do we know B?
Because it's where 0 is.
Okay. When we start talking about B, our y-intercept, it's on the y-axis when x equals 0. So we have B as 68.2. What about slope then? Because we have to find intercept, which we know now. What about slope? Angela?
We do the equation to find slope, so m equals y2 minus y1 over x2 minus x1.
Okay. You guys hear her? I always say change in y over change in x, or y minus y over x minus x, specifically y2 minus y1 over x2 minus x1. So we need two ordered pairs to do that. Well, what's one we should use?
The first one.
Okay, we should use this 0 and 68.2 because it's our y-intercept. It's going to be, we're definitely including that. And then my recommendation to get the line that best goes through these points. I mean, if you, oh, my graph turned off. You know, if you have two that definitely look like they're on the line, that's one thing. But other than that, I'm going to suggest you go with the last one. Okay, so using the last one, we're using the ordered pair 60, 78.7. Let's find our slope. Okay, change in y. y2 minus y1. Doesn't really matter which way you subtract these y's, as long as you're consistent. So I'm going to say 78.7 minus 68.2 over, subtract your x's, and we're doing 60 minus 0. Well, 60 minus 0 we know is 60. 78.7 minus 68.2. 10.5. What is 10.5 divided by 60?
7.
What was it?
0.175.
Okay. Not at all what I heard you say at first, so.
No, that's a fraction.
Oh, okay. Yeah, I wasn't going to go fraction. We could go fraction, but this one, it's a nice neat decimal, so. Okay, guys, so we know our m. We already talked about our y-intercept being 68.2. So what's that make our equation? Y equals, fill in the pieces, 0.175x
Plus 68.2.
plus 68.2. There is your linear form. Now, let's verify. I think some of you guys were a little hesitant to agree to that this is just a line. You guys wanted it to be something fancier, didn't you?
Yeah.
Okay, but if we go to your y equals and type in that equation we just came up with, 0.175x plus 68.2. And you will see that it goes through those points very nicely. Okay? Mine does at least.
It doesn't touch one.
No, but I mean, it's not going to touch exactly every single point. You'll notice it touches the first and last point for sure, because those are the points I used.
So then,
And then it's right in the area of all the other points. It's a trend. It's a model. It's not going to be exactly on every single point every time. Okay? Okay. Questions I need to answer here. Calculator issues. We have to know how to use the calculators, right? Okay. So you'll see a little bit of that when you get to homework. We do have one other page of notes, though, and that is solving some equations. Shall we solve some equations? As you scan down the page, you'll notice the first two say solving equations algebraically, and then when we get lower, we'll talk about solving equations graphically. So, graphically, I get it, not as much work to show. Algebraically, I expect to see some work. Okay, so this is reviewing skills that we've already talked about some this year, but we're going to talk about more. So A, 6x cubed equals 11x squared plus 10x. You got a starting step for me, Jack?
Yeah, you gotta subtract the 11x squared and 10x, so it's all equal to 0.
Okay, so somehow or another, make your equation equal to 0. Okay, I actually agree and like the idea of subtracting the 11x squared and the 10x over because I like to keep a positive first term. It's not necessary, but I like to keep a positive first term. If you prefer to subtract the 6x cubed over, you're going to have negative 6x cubed. That works, but I'm going to suggest that you then divide everything by negative. Okay? So, subtract 11x squared, subtract 10x. So what do we have here? 6x cubed minus 11x squared minus 10x equals 0. Okay? We made it equal 0. I need another step. Angela? Change the word from divide out to x. I don't like the word divide. Factor out x. And here's my reasoning. Maybe not how you think of it, but when I hear the word divide out, I'm going to divide everything by x, and I'm going to get rid of the x from my problem, which means in this case I'd be getting rid of an answer. When I hear the word factor out x, well, yes, I am dividing each term by x. What am I going to do with that x? I'm going to put it out front, and I still have it. So that's my reasoning for being nitpicky when you guys say that. But okay, so I'm going to factor out an x. 6x cubed divided by x is 6x squared minus 11x squared divided by x is 11x minus 10x divided by x is 10. Okay, so far so good. We made it equal to 0. We factored out that GCF of x. I should have thrown that word out there, GCF. Next. Jack?
Product of AC.
He says product of AC.
no. Oh, yeah.
Are you saying no because you're going to slip and slide instead?
No, I was.
Because here's the deal. You're either going to product of AC or you're going to slip and slide. Personal choice, I don't care what you do, but. Or you're saying no because you're like, I just don't want to do it. But,
I just.
yeah, we're going to do it. Okay, product. What do I need a product of?
A and C.
A and C, which is
60.
6 times negative 10, so negative 60. What do I need a sum of? The B term, which is negative 11. Start going through your pairs for 60 if you're not sure. 1 and 60, 2 and 30, I don't know. So,
What is -15?
I just know it's somehow 4 and 15, so sounds good to me. Okay? -15 and 4. What do I do with that -15 and 4?
Oh, go the middle.
We're going to use them to split our middle x term, yes? Now, as we go about this, everything else carries down, so that x out front carries down. 6x squared carries down. Minus 11x. Somehow you're using minus 15x and plus 4x. I'm personally writing minus 15x plus 4x. And then carrying down my minus 10. You can reverse those two if you want. You'll meet me in the end. That's fine. Okay. The x out front, keep carrying it down, don't lose it. What do I do with these 4 terms? Factor or how?
X for the first, then we do 3x.
Okay, because we're splitting these 4 terms in half, right? Officially, if I use proper vocabulary, this is factor by grouping when you have 4 terms. So, GCF of the first 2. Did I hear 3x?
Mm-hmm.
So 6x squared divided by 3x is 2x. Minus 15x divided by 3x is 5. Okay, GCF of the next 2. 4x minus 10.
X. So then there's a 1. 2.
I like 2. 4x divided by 2 is 2x minus 10 divided by 2 is 5. Okay. And I don't know if you guys noticed, I threw in some brackets there just because I don't want that x to get lost. I don't want to get mixed in. So x out front, what am I still doing? Carrying it down. And if you recall, this factors into 2 parentheses, right? 1 parenthesis comes from the GCFs of 3x plus 2. The other parenthesis comes from the matching parentheses of 2x minus 5. These are all skills we know, right? Okay, what's next? It's the easy stuff. We're almost there. Angela?
Set everything equal to 0.
Yeah. Set each factor equal to 0 is how I would say it. How many factors am I saying equal to 0 in this one?
3.
3. Because x matters, doesn't it? This is why from the very beginning I said you can't lose the x. So we're going to say x equals 0. 3x plus 2 equals 0. And 2x minus 5 equals 0. Get your solutions. X equals 0. For 3x plus 2, if I subtract 2, 3x equals negative 2, and x is negative 2/3. For 2x minus 5, add 5. 2x equals 5, and x is 5/2. And we have 5 answers. There's 5 answers. 3 answers here. Okay. It's not a coincidence. What was the highest power in this problem when I started? It was a 3, yes? How many answers did I come up with?
3.
3. That's not a surprise. That's what you would expect to happen. Is a power of 3 means you're going to have 3 answers here. Okay. That was review, right? Putting it all together. Okay, well let's try B then. Square root of x plus 1 plus 3 equals 2x. Where to start? What do we remember?
You need to get the square root by itself, so you can square it.
Okay. So isolate the square root. Anytime you have any type of root, square root, cube root, whatever, we're going to isolate it. So in order to get this square root by itself, we're going to subtract the 3 over. So I have square root of x plus 1 equals 2x minus 3. Now what?
Get rid of the square root.
And to get rid of the square root, I'm going to square both sides of the equation. What is the square root of x plus 1 squared?
X plus 1.
Yeah, the square and square root cancel each other out. X plus 1. What about 2x minus 3 quantity squared?
4x squared minus 6x or minus 12x plus 9.
Are you guys with her?
No.
She said 4x squared minus 12x plus 9. And I'm not disagreeing with her, notice.
She's right. Why is she right?
Because she foiled.
Because you put her in parentheses.
Okay, so common wrong answer. There's a whole bunch of you out there thinking 4x squared plus 9. Because that's what we always do when we haven't done this in a while, is we forget the middle terms. But yeah, officially, you are taking 2x minus 3, multiplying by 2x minus 3, which means you are foiling. If you need the visual, write it out. If you can foil in your head, awesome. So I have x plus 1 on the left. On the right, first, 2x times 2x is the 4x squared. Then outsides, 2x times minus 3 is minus 6x. Insides, minus 3 times 2x is another minus 6x. Minus 6x and minus 6x is minus 12x. And minus 3 times minus 3 is plus 9. Okay. Now what? What are you thinking?
Get everything on the side.
Okay. When your highest power is an x to the second, general rule of thumb is you want to make your equation equal to 0. Like I said earlier, I like to keep my x squared term positive. So I'm going to leave the 4x squared on the right. I'm going to subtract x over. And I'm going to subtract 1 over. For me, that puts my 0 on the left. On the right, what's this become? I'll take the first term, 4x squared. Then what? Minus 13x and plus 8. Okay. Now what? Product of AC. So let's see, product of AC, what are we doing? Product of 4 times 8, which is 32, and a sum of middle term B, which is negative 13. What What are we coming up with? What are we coming up with? Are we stuck?
Yeah.
So when I'm stuck, I go through my options. Product of 32. So 1 and 32? 1 and 32 doesn't get me to add or subtract to be 13, does it? Okay. 2 and 16. Can 2 and 16 become 13? No. 3 doesn't go into 32. 4? 4 and 8. Well, 4 and 8 can't become 13. 5 doesn't go into 32. 6 doesn't go into 32.
Not possible.
7 doesn't go into 32. And now I'm back at 8, which we've already used 4 and 8 as an option. So when product of AC fails, or when factoring fails, quadratic formula is often our go-to method. So instead, we want to talk about our ABC values, right? So A is 4, B is negative 13, and C is 8. I think some of you had that figured out. You were just hoping you were overlooking something, weren't you? Okay, quadratic formula. Here we go. X equals negative B. So negative B is going to mean 13 plus or minus the square root B squared. So negative 13 quad squared minus 4 times A, which is 4, times C, which is 8, all over 2A, 2 times 4. Okay. 13 plus or minus negative 13 squared. Now, first of all, use your brains. Don't let the calculator take you wrong. Negative 13 squared is going to be what? And that's a positive 169. I've still got people making that mistake where they see that negative and they square it. And I don't know if it's their brains or their calculators misfunctioning, but it is going to be a positive. Minus 4 times 4 times 8. 128. And it's all over 8. So 13 plus or minus 169 minus 128 is 41, all over 8. Okay. Thoughts? What about the square root of 41? Is it a perfect square?
Yeah.
No. Are there any perfect squares in it? That's the catch.
No.
No. 41 is prime. It's just 1 times 41, so that's not going to happen. So you could leave your answers that way. If there was a need to go decimals, you could punch into your calculator and get a decimal. The other option, if you recall from when we were doing the A plus BI form, and I'm not requiring it here, but the other option is you could say 13 over 8 plus or minus the square root of 41 over 8. I'm perfectly fine with the first option. The only time I kind of push you to go into the two separate fractions is when it's complex forms and we're dealing with the imaginary numbers. Okay. Questions there? Okay. Let's let's look at a little bit of these graphing ones. First of all, note, it says right up front, solve each equation graphically, yes? Because do we know how to solve something that has absolute value and a square root in it? Probably not, okay? And that's why we're going to go with solving this graphically. Now, how do we solve graphically? What am I saying here? Okay, it needs to be y equals so we can type it in on the calculator. Which means, in this sense, you need to make your equation equal to 0 to begin with. When you get to the homework, I believe it will be specific, and it will ask you, when to solve this graphically, to make your equation equal to 0 on the right-hand side. In other words, when you make your equation equal to 0, you technically can do it either way, but they're wanting us to all do the same and make it equal to 0 on the right-hand side. So with this in mind, A, the absolute value of 2x minus 1 equals 3 times the square root of x plus 6. How do I make that equal to 0 on the right-hand side? What's that mean? All of this right here has to move to the left. Right now, it's 3 times the square root of x plus 6. How can I move that over to the left? Subtract it? We're going to do just that. We're going to subtract the term 3 times the square root of x plus 6. Because it's one radical with a number multiplied in front of it, we can move it all as 1. So we're going to subtract 3 square root of x plus 6. So when I write this out, absolute value of 2x minus 1 minus 3 times the square root of x plus 6 equals 0. Once you have it equal to 0, that's what you're typing into the calculator. So you're going to graph the equation y equals absolute value of 2x minus 1 minus 3 times the square root of x plus 6. Do not try and do anything with that absolute value. Keep it as is. It doesn't become 2x plus 1. It doesn't, nothing changes with that absolute value. Keep it as one quantity there. Okay. Are you on your calculator now? Everyone needs to be. Now, okay, a couple of things. First of all, before you go into graphing, you're going to need to turn your stat plots off. Stat plots sometimes can stay on, sometimes they can't. Easiest way to turn your stat plots on and off. Are you ready? Go into your y equals screen. First of all, I can clear that line. But you see up where it says plot 1 and plot 1 is flat, it is dark? If you go up there and hit enter, now it's no longer dark. Plot 1 is turned off. That is your easiest way to turn stat plots on and off. It's also, unfortunately, the easiest way to accidentally turn them on and cause a problem. So now my stat plots are all off. Let's type in our equation. We haven't talked about where absolute value is yet, have we? Okay. Absolute value can be found in two different places. I'm going to go the long way first, and then I'll show the shortcut, because I think the shortcut will work on everyone's calculators. The long way, here's what I'm going to tell you. Most anything you want can be found in the math menu somewhere. The math menu is quite big. If you go into the math menu, I believe absolute value is if I go over here to the right arrow, one to the right to num, the num menu, ABS, number 1, is absolute value. If I hit enter, it takes me back, and my absolute value bars are there, yes? That's one way to get there. That was kind of the long way. You want the short way? You'll like the short way better, I think. These green, they're green on my calculator. F1, F2, F3, F4, F5. Those are menus. You get to them by going to alpha. If I go alpha, I think it's F2. Alpha and F2, which is the window menu. You have a lot of options here. The best one right here, number 1, is ABS, absolute value. So there's your absolute value. Type in 2x minus 1. Arrow out of it. Minus 3. Square root of x plus 6. Now, when you go to your graph, we just had some funky window going on, didn't we? What have I taught that you should use to get back to a normal window? Zoom 6. Zoom. Good. And you can just type 6, the 6 for standard, and that'll take it to 10 by 10. Does your graph look like my graph? Does your graph look like my graph? Okay, and to finish it off, and we'll finish it off tomorrow, you find the zeros, the x-intercepts, which you know how to do. Left bound, right bound, and yes. We'll do that tomorrow. Okay, homework. So tomorrow, we'll do a little bit more of this graphing. You'll have some work time. I don't know, we might check homework at the end of class tomorrow, but more than likely we'll check homework on Thursday. Okay? You can start working on it tonight if you want. You know a lot of what you're doing.
Well, we're doing